Can you believe that even students can understand the principle of the cloth band motor used by the high-precision robotic arm? We know that when you wrap a copper wire around a metal, it creates a magnetic field when energized. If the current direction is switched, the poles are switched. Now replace it with two pieces of metal and wrap it around a copper wire, which will generate magnetism when energized. Put metal in the middle, and it will be attracted to both sides and straighten. Next, two more sets of coils are added, and the middle rotor is changed to a cross shape. When the coil is energized, the rotor is attracted, and switching the B coil continues to be attracted again. Just switch the power all the way in order. The rotor can be rotated clockwise. Pay attention. The angle at which the rotor moves once is 30 degrees. Imagine this motor connected to a robotic arm. Every 30 degrees is an azimuth. You can only capture these 12 positions. Then, if you want to grab the middle areas. So how to achieve it? Back to this structure. Now the coil is powered on at the same time. Coil B is also energized. At this point, the rotor is attracted to the two-phase stator, just in the middle. Then the coil is disconnected. The rotor is rotated another 15 degrees to align the B coil. Just keep looping in that order. You can get a 15-degree non-entry mat machine. But now every 15 degrees is azimuth. Only these 24 positions can be caught. What else can be done? I can capture it from every angle as much as possible, according to this model. Now replace the rotor with this structure. In the middle is a permanent magnet of N and S grades. Two pieces of highly conductive steel are connected. If you look closely, there are 50 teeth on the edge of the magnetic steel body, and the steel bodies on both sides are staggered from each other. Look at it from the front. This is what the rotor looks like. Facing us is the S-class. The next step is to make a magnetic steel body corresponding to the toothed structure. Wrap the rotor. Each tooth corresponds to 1 by 1. Remove 2 teeth from the outside. The external ones were then divided equally into 4 groups. Each group has 6 teeth on one side. First, the teeth of Group A and rotor are aligned. Groups B and D remain semi-aligned. Group C is completely staggered from the rotor. The next step is to put the exterior high-conductivity steel body. Make it this shape, and stack multiple pieces of highly conductive steel on top of each other. 4 of them will be crossed opposite each other. Connect in a circle with a thread. Pay attention to the direction of the circle. This makes the stator poles in the opposite direction consistent when energized on. For example, switching the direction of the current. The magnetic poles will also flip. Connect the other 4 together in the same way. Now we get 2 sets of coils. First, power on the No. 2 coil. Group B2 windings produce N grade. Group B2 windings produce S grade. And the rotor facing us is the S-class. According to the principle of opposites attracting and same-sex acquaintances, the overall rotation occurs by 1.8 degrees. Let's look at it again. This process is exactly from a semi-aligned state. Move to alignment. Exactly a quarter of a tooth angle pitch. That is 360 degrees. Divide by 50 teeth to get a spacing of 7.2 degrees. Divide by 4 to get 1.8 degrees. You can see that the part that attracts is aligned. The repulsive part is the staggered state. Switch the No. 1 coil to power on. It will move 1.8 degrees again. Then replace it with the No. 2 coil. Note that this time the current direction is reversed. To continue to attract movement, cycle in this order. The motor can be turned. Then move 1.8 degrees each time. That is, it can accurately control 200 directions. Let's look at the back. The drill is the opposite of the magnetic machine, and it is a staggered relationship with the opposite side. The advantage of this design is that the torque of the motor can be increased. Then this set is the principle of hybrid stepper motor.